excited that you're watching this video. Way to take your reviewing into your own hands. I'm going to go through the study guide and I want you to do the work alongside with me. You can absolutely rewind or pause. Think about your thinking, think about where you are with these skills. We're really just focusing on comparing fractions, thinking about how many, according to the denominator, how many pieces is the whole cut into, how big are the pieces. You guys know if the whole's cut into 8 pieces, those pieces are going to be pretty small, versus if the whole's cut into 2 pieces, those are going to be pretty big pieces. So we're doing lots of comparing fractions. We're also doing a lot of work around equivalent fractions. So we're going to take a run through those. And again, I'm so excited that you're watching this, and really, I would love to celebrate you being so responsible and doing your best to be ready for this test, or being ready for a celebration of learning, which is going to be Wednesday. So maybe you can watch this a couple times. Keep your eyes out for our secret image, and be sure to write that down. But let's go ahead and get into the work. Here we go. Okay, my people, we are going to begin at the beginning. Take a look at number 1 here. So we have 3 sets of fractions, and we are comparing them. First up, we have 1/2 and 2/4. Our most reliable way to compare fractions is just to use my free of charge super duper fraction comparison machine. You guys can use it free of charge through 3rd grade. So I just highly recommend, instead of guessing is not a strategy, just go ahead and draw the 2 fractions, shade them in so you can see what they look like. And again, we're doing this because the numerators are different and the denominators are different. So as I'm drawing just this really quick model, 1/2, you can see is cut into 2. I shaded in 1, and then 2/4 I'm cutting into 4 equal parts, and I'm shading in 2. So I'm looking at 1/2 versus 2/4, and this is the one that I'm noticing, oh my gosh, these fractions are equal to one another. These fractions are equal. These are equivalent fractions. This is like a classic equivalent fraction. 1/2 is equal to 2/4. And we can prove that really quickly by just using a little bit of multiplication. So if we want to convert 2 into 4, well, I could just multiply that by 2. We know if we're multiplying 2 by 2, we also have to multiply 1 by 2. So 2 times 2 is 4, 1 times 2 is 2. 1/2 is equal to 2/4. We showed that using multiplication and our model. So I feel very, very good about that. B is kind of funny because I don't really care for these diagonal fractions. I like to rewrite them like this. So I'm looking at 7/8 versus 2/8. And what do I immediately notice? I hope it's the same thing you're noticing. Denominators are the same. Whoop, whoop. So all we have to do is think, 7 versus 2. 7/8 versus 2/8. Which one is larger? 7/8 are larger. I love, love, love when those denominators are the same. Well, that was fun while it lasted, because in C you can see, get it, that the denominators are not the same, the numerators are not the same, and that's okay because we can still use our handy dandy fraction comparison machine free of charge. I have some really pretty purple flowers that just sprouted out in our garden, so I'm going to choose the same color that they are. I'm not guessing at which one is bigger, 1/6 or 3/4. I'm just going to go ahead and draw them so that my brain feels good about my answer that I'm going to provide. We are going to show 1/6 on the top. We are going to show 3/4 on the bottom. I'm going to pop 1/6 into 3 equal parts, and then I'm going to divide those each into 2 equal parts so that I have 6 fairly equal parts. It says equal. We're going to pretend that those are quite equal, but we're always going to do the best we can to make those look super, super equal. So I've shaded in 1/6, and my next job is to shade in 3/4. So I'm going to cut this into 4 equal parts, and then I'm shading in 3. I think by the time you start shading, it's pretty obvious which one is larger here. 3/4 is only cut into 4 equal pieces, so those pieces are pretty big. And then when we're looking at 1/6, you can see those are 6 equal pieces, and we only have 1 shaded. So it's quite apparent that 1/6 is less than, much, much less than 3/4. So I can go ahead and put that symbol in there. As we're looking forward to number 2, we see Mark and Lisa are on the swim team. Mark swims 3/8 of a mile each day. Lisa swims 5/8 of a mile each day. Which statement is correct? So I'm very excited to see that we have the same denominator. So Mark is at 3/8. Lisa is at, I have to put my nose up closely, it's kind of small, is at 5/8. So, woohoo, I love comparing fractions that have the same denominators. They're cut into equal pieces, so essentially all we're comparing are the numerators, and that's quite straightforward, which I love. So let's look at all of these. I'm noticing it says choose all that apply. So my brain's kind of thinking there might be more than one answer. So we're going to look at all of the options, cross out what doesn't make sense, and then circle what does make sense. So our first option is Mark swims farther than Lisa each day. Well, if you were to swim farther, that would mean 3/8 is bigger than 5/8. That is simply not true, so I'm going to cross it out. Lisa swims the same distance as Mark. Well, is 5/8 equal to 3/8? Not last time I checked, so we're crossing that one out as well. C. Lisa swims less than 1 mile each day. Well, I didn't put our units in here, but these are 3/8 of a mile and 5/8 of a mile. I know 1 mile would be equal to 8/8, and I know that she swam 5/8. So did Lisa swim less than 1 mile? Did she swim less than 8/8? Yeah, she did. She swam 5/8. Okay, cool. We're going to circle that one. That one makes sense. And then let's look at D. Lisa swims farther than Mark each day. 5/8 bigger than 3/8. Ding, ding, ding. So C and D are what we're looking at for number 2. Okay, my friends, we're going to look at 3, 4, and 5 next. These are the final pieces that are on that front page. Number 3, we are going to write true or false for each of the following. I'm looking at 3/4 is larger than 3/8. I'm just going to quickly think about that in a very, very, very fast, super fast model that is kind of skinny and maybe the lines aren't so straight. But I'm thinking about 3/4. I'm thinking, those pieces are pretty big because this whole is only chopped into 4. So I'm looking at 3/4. And then I'll put 3/8 on this bottom row here. So 3/8, well, the whole's going to get cut into 8 pieces. And we're only shading, 2, 4, 6, 8, beautiful. We're only shading 3 of those. So I know with 3/8, I know the whole is getting cut into 8 pieces. Those pieces are pretty small, as you can see. With 3/4, well, our whole only got chopped into 4 pieces, so those pieces are pretty big. And I feel really comfortable, yes, our model shows that 3/4 is bigger than 3/8. So I'm going to say a T for true. 2/6 versus 2/8. Okay, keep in mind, again, my friends, I know it took a lot to kind of retrain our brains into thinking about these denominators as slices. And I wish I just had a little bit more room here. Let's look at 2/6 and 2/8. Why is it not letting me draw? I'd like to draw now, please. Draw. Okay, there we go. 2/6 versus 2/8. I'm not even going to think about what this statement says yet. First, I want to figure out exactly what's going on with 2/6 versus 2/8. So I'm going to make a model showing sixths. I'm shading in 2 because this top row is going to be 2/6. And then this bottom row is going to show us eighths. So you guys know that means I have to cut the whole into 8 equal pieces, which is a lot of pieces. And then I'm only shading in 2. So when we're looking at 2/6 versus 2/8, my friends, I think you see what I see. 2/6 is not less than 2/8. 2/6 is actually, can you see how 2/6 is bigger? When we're looking at 6, the slices are a little bit larger than the 8s, aren't they? So if someone's trying to tell you 2/6 is less than 2/8, you need to tell them that they are wrong. That is false. True statement here would be 2/6 is larger than 2/8 is greater than. Moving on to 3/3 and 6/6. 3/3, my friends, I think you're probably thinking what I'm thinking, is a fancy version of 1. 6/6, my friends, is a fancy version of 1. we know that 1 is equal to 1. So in turn, 3/3 is equal to 6/6. So that is going to be a ding, 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 true statement. I am going to choose another color. Let's look at like a nice, bright, lovely blue. Yeah, turquoise. How about a nice turquoise? My friends, we are now ordering fractions. For number 4, we are looking at least to greatest. We're looking at smallest to biggest. I'm looking at 3/8, 3/4, and 3/12. So let's do this. Let's just look at a triple decker fraction comparison model. And let's imagine, well, we're not going to imagine, we're actually going to see it with our own eyes. We're going to look at the top row is cut into 8 equal pieces. And as I'm slicing this whole, I want you to look at all of those slices. Those are pretty small, right? The middle, so this is 3/8. The middle is going to be 3/4. So our middle fraction only has to be cut into 4 equal pieces. And then, my friends, our bottom fraction is going to be 3/12. Well, you thought those 8ths were small. Wait until we look at these 3/12. I'm trying to figure out how we can do this. So we've got 3. Now we've got 6. And now I have to split all of these 6ths into 2 equal parts. Good grief. So my friends, when we're looking at 3/8, those pieces are pretty tiny. I'm not interested in 1/8 of a cake. I am pretty interested in 3/4 of a cake or even 1/4. Those slices are pretty legit. These 12ths, please don't bother me offering me 1/12 of a cake. Those slices are teeny, teeny, tiny. So we know the more slices, the tinier the pieces. So let's really think about putting these fractions in order from least to greatest. The fraction with that big old denominator, the fraction where you cut the whole into 12 equal pieces, that's going to be a tiny fraction. That's little, right? These are 12 pieces and you get 3 of them. I hope you guys also notice that all 3 of these numerators are the same. So really what we're doing in this problem, my friends, is comparing the denominators. Okay, so those are tiny slices. They make me feel a little upset. Let's look at, so we've handled that. Let's look at 3/4. That whole is only cut into 4 slices. Those are pretty big slices. I feel pretty excited about that. So 3/4, so those are going to be the biggest slices. And then 3/8, that is going to be the fraction right here in the middle. So when we're looking at these fractions, putting them in order from least to greatest, we're looking at 3/12. That whole was cut into 12 equal bits. Then 3/8, that whole was cut into 8 equal parts. And then 3/4, this whole was cut into 4 equal parts. Oh, I'm very excited to see number 5. I'm very excited to see that these fractions have the same denominator. So I feel like the heavy lifting is kind of done for us. Here, though, it's very important. The instructions say we're putting these in order from greatest to least. So out of 6/6, 3/6, and 4/6, which of these fractions is the biggest? Well, 6/6 is the greatest. It's the biggest. We know that it's actually a fancy version of 1. Which one is the smallest out of 3/6 and 4/6? Which one is the least? Well, that's going to be 3/6. So we've placed that. And then the one in the middle here is going to be 4/6. So we're looking greatest to least. 6/6 is the biggest. Next, we have 4/6. And then 3/6 is the least or the smallest. Okay, my friends, now we're going to get into some work around equivalent fractions. So here on number 6, we see 2 steps. Step 1 is to shade the model to show 2/4. Well, it's so nice because we have this circle. The denominator is 4, and it's so nice that it's already been cut into 4 equal pieces for us. Now, all we need to do is shade 2 parts of this circle because the numerator is 2. So I feel like you guys could probably do that in your sleep. That is pretty easy. Beautiful. Moving on to step 2. Now we're going to divide the pieces of this circle, to find the equivalent fraction below. So we have 2/4 is equal to some equivalent fraction. This equivalent fraction is going to have a denominator of 8. So let's use multiplication to figure out what this equivalent fraction is going to be. So I'm thinking, 4 times some number is 8. What? How many times do I need to multiply 4 to get 8? 2. You're right. Yes, 4 times 2 is 8. Excellent. And we know if we're going to multiply 4 by 2, we have to multiply 2 by 2 because we need to treat the denominator and the numerator the same way when we're looking at equivalent fractions. So 2 times 2 is 4. This is beautiful. So what we've just shown using multiplication is that 2/4 is equal to 4/8. So we found that equivalent fraction. And now we're going to show that. This is where we're doing like that kind of double duty modeling. So now we showed 2/4 in red. And now in order to show the equivalent fraction, I'm not changing the shading. I'm just changing the cuts. So instead of 4 equal pieces, now we're going to look at this circle cut into, did I say 4 equal pieces? I hope so. Now we're going to look at this circle cut into 8 equal pieces. Are you guys noticing that I'm cutting each of the original 4 pieces just into 2 equal parts? So now you can see we have 1, 2, 3, 4 shaded. And now our whole circle is cut into 1, 2, 3, 4, 5, 6, 7, 8. So originally we were looking at 2/4, but now looking at the equivalent fraction is showing us 4/8. So that is a really nice way to model and show that. We're going to look at another way to model. This time, instead of a circle, we are going to check this out on a rectangle. So same idea, different shape. So here we're going to circle equal groups to find the equivalent fraction, then fill in the missing number. Okay, so let's see what we're starting with. We see 1, 2, 3, 4 right here out of 1, 2, 3, 4, 5, 6, 7, 8. So the original fraction we're starting with, my friends, is this shaded part, right? 4/8. But we're going to add on to that. That's kind of what we learned last chapter. Now we're going to think about, well, yeah, it's 4/8, but it's also something else. So this is another model that's going to kind of be double duty. So now I'm looking to find an equivalent fraction. We're not changing the shading at all. We're just looking at the partitions in a different way. So yes, this is 4 out of 8, but it's also, do you guys see how it's also 4 equal groups? So I'm going to circle these rectangles, but because yes, absolutely, it's 8 rectangles, but it's also 4 equal groups with 2 inside each. So we're going to try to figure out, well, what is that equivalent fraction? 4/8 is equal to some amount of 4s. And now, instead of multiplication, we're going to go the other way. We're going to think about division. 8 divided by some number is going to get us to 4. Same up here. 4 divided by the same number is going to get us this is going to help us fill in the blank here. I'm thinking, well, 8 divided into 2 equal groups gives us 4. And then let's treat the numerator the same way. So we did 8 divided by 2, and now we'll do 4 divided by 2. Well, 4 divided by 2 is 2. So what we've just shown using division here is 4/8 is equivalent to 2/4. We can see the original was shaded in gray, but now can you also see, maybe I'll shade this like in yellow. I'm not changing the shading, I'm just kind of shading over our original with yellow. Can you also see how this model is showing us 2/4? So we have 2 out of the 1, 2, 3, 4 columns shaded in. So again, these are both really, really good examples of those double duty modeling that help us see these equivalent fractions. Not only are we modeling them, but we're also showing the work using either multiplication or division, again, treating the numerators and the denominators exactly the same. Okay, my friends, here's another awesome opportunity to show those equivalent fractions. Just thinking about finding a match to go with this awesome green. And for here, we are looking at 1/4. My eyes, well, we don't want to do a highlighter, Mrs. C. Let's try that again. My eyes just like seeing a fraction written vertically. It just makes me feel better. Okay, so 1/4. We're looking at 2 other versions of 1/4 that we can consider equivalent fractions. So let's just go ahead and, whoa, oh dear. Let's go ahead and, I need this to be a little bit thinner. Hang in there. Let's go ahead and create 2 equivalent fractions using simple multiplication. So 1/4 is equal to some equivalent fraction, I know that I can create an equivalent fraction by multiplying the numerator and the denominator by the same number. And again, we're going to keep it really simple. So I'm choosing 2 here because my brain likes simple numbers. So I'm asking you all, what is 1 times 2? And I'm hearing you all tell me, Mrs. C, 1 times 2 is 2. And I'm saying, very good. What about 4 times 2? Indeed, 4 times 2 is 8. So what we've just created here is an equivalent fraction by multiplying 1 and 4 by 2. So here we have 1/4 is equal to 2/8. Okay, so our equivalent fraction is going to be 2/8. And we are just going to go ahead and show that and partition this. I'm going to do my best to make those all look very, very nice and even. I'm going to create, first I created 4, and now I'm cutting each of those fourths into 2 equal parts to show that 1/4 and 2/8 are what we call these equivalent fractions. So make sure that we're shading not too much. I want to make sure that we can see the partitions. So that's pretty close. 1/4 is equal to 2/8. Well, now we have to come up with another equivalent fraction. Again, we're still looking to come up with an fraction that's equivalent to 1/4. So in the spirit of being really simple, we already used 2 to come up with an equivalent fraction. The next number that makes sense would be 3. So let's multiply the numerator and the denominator by 3 to come up with another fraction that's equivalent to 1/4. So I'm thinking 1 times 3 is 3, wonderful, and 4 times 3 is 12. So now we've created yet another equivalent fraction that is equivalent to 1/4, and all I need to do now is go ahead and model 3/12. So I'm starting with a 4, and I'm going to do my very, very best to cut each of these 1/4 into 3 equal pieces, transforming our fourths now into 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I'm very carefully going to shade in 3. And as you look across these 3 models, you can see that it's very, this we're going to have to kind of maybe squint one eye, but what we've shown using multiplication is that 1/4 is equal to 2/8 and is equal to 3/12. Those are what we call 3 equivalent fractions. And again, when we're doing these, my friends, keep it simple. I feel like when we're coming up with these equivalent fractions, use 2 and 3. We don't need to be going crazy and multiplying the numerators and denominators by super big numbers. Okay, let's go on to our next problem. Okay, my friends, we're moving on to numbers 9 and 10 here. And number 9 reads, Jackson rode his bike 1/4 of a mile. Oliver rode his bike for an equal distance. Which fraction below is equivalent to 1/4? So we are looking at which of these fractions is equivalent to 1/4. So let's think 1/4 versus 1/5. Well, we know that 1/4 and 1/5 are simply just not equivalent fractions. I'm going to cross that out. Again, we see choose all that apply, which could lead us to believe that there's more than one answer here. So make sure you evaluate all of our options. Let's think about 2/8 versus 1/4. And we can just use a little bit of multiplication to consider, is there any possibility that 2/8, oh dear, what's happening here? Excuse me. Is there any possibility, are you going to work with me? Dear, come on. There we go. That 2/8 is equal to 1/4. Can we, actually, I'm going to do this. Do this the other side. We can write this either way, my friends, but I feel like this just feels better in my brain. Is there anything we can do to 1/4 to make it 2/8? Could we multiply 4 by something to get 8? Well, yeah, we can multiply it by 2. 4 times 2 is 8. Well, and if we're going to multiply 4 by 2, we have to multiply 1 by 2. 1 times 2 is 2. This proves, my friends, that 1/4 and 2/8 are equivalent fractions. That totally works. Let's look at 3/12. 1/4, is there any possibility that we can multiply 1/4 by anything to make it 3/12? I'm looking at 4 and 12, and I'm looking at 1 and 3. Well, I know 1 times 3 is 3. If I multiply 1 times 3, I have to multiply 4 times 3. What is 4 times 3? 12! Woohoo! So we've also just shown, my friends, that 1/4 is also equal to 3/12. Fractions can have many, many, many versions of equivalent friends. It's just a matter of multiplying the numerators and the denominators. Honestly, we could play this game all day where we multiply 1/4 by 2 over 2, 1/4 by 3 over 3. We could multiply it by 4 over 4 and 5 over 5 and 6 over 6. You can do that all day if you're feeling bored. We're not going to, but I just want you to know that fractions can have many, many, many equivalent counterparts. Finally, let's look at 2/9. I'm looking at 1/4 potentially being equivalent to 2/9. And I know this is never going to happen because 4 times, there's no number that I can multiply 4 by to make it 9 because 9 is odd. Or you could think, well, 1 times 2 is 2, that works. But does it work for the denominator? 4 times 2 is not 9. So absolutely, that does not work. We have our 2 equivalent fractions there, and that makes me feel good. Beautiful. My friends, we can use a few different strategies for number 10. Can you draw a super duper fraction comparison machine free of charge? Yeah, you sure can. Actually, they're just so much fun to use. I'm going to draw one. I don't like the way, my only hesitation is I don't really feel confident with drawing 5 equal parts, but I'm gonna spread my wings. So I'll draw 1/4 first. I know that 1/4, the pieces are gonna be bigger than 1/5 because now I have to slice this puppy into 5 equal parts. And I can just see my slices of chocolate cake getting smaller, which makes me feel a little sad. Okay, so 1/5. The slices are smaller because I sliced the top one into 5 equal parts. 1/4. The slices are a little bit larger, as you can see, because this whole was only cut into 4 equal parts. So when you're thinking about this and you're comparing 1/4 versus 1/5, yes, indeed, you know that 1/4 is larger because, again, this whole is only cut into 4 equal parts. So when I'm trying to figure out which statement is correct, I have my model here, I have my statement here, so I feel very confident as I'm going to evaluate these options. 1/5 is larger than 1/4. Not true. 1/4 is larger than 1/5. Ding, 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 ding. We know that's true based on our model, based on what we know about denominators, and based on kind of just the logic that we were using. 1/4 is equal to 1/5? No, that makes no sense. Not possible, ever, ever, ever. 1/4 is less than 1/5? No, that's also not possible because we know 1/4 is bigger. So this is really, really nice that we're able to be super confident in our final answer, which is B for number 10. We are looking at 11 and 12 next. 11 shows us that Alan solved 3/6 of his math test in Mac. Oscar solved 3/10 of his math test in Mac. Write a comparison statement using greater than, less than, or equal to show which fraction is greater. So I'm just thinking about comparing these fractions. I notice the numerators are the same, but the denominators are different. And when I'm thinking about 3/6, I'm thinking, okay, so this whole is going to be divided into 6 equal pieces because the denominator is 6, and then we're shading in 3. So 3/6, okay, 3/6 is equivalent to 1/2. And now I'm looking at comparing that to 3/10. So immediately I'm thinking, oh gosh, okay, now I have to cut this into 10 equal slices. That's a lot of slices. So I immediately know these slices are going to be pretty small. So as I'm doing my best to cut these into fairly similar size slices, I know this could be better, but we're just gonna try our best. I can see, gosh, these tenths are skinny because we had to slice that whole into 10 equal pieces, for crying out loud. 6, still, they're pretty small pieces, but they're not as small as 3/10. So when I'm looking at which is bigger, 3/6 versus 3/10, you guys can see, same as me, that 3/6 definitely bigger than 3/10. Again, think about your denominators. Think about that this one was cut into 10 pieces. Think about how angry I am about having to share my cake with 9 other people. Ay, ay, ay. This, 6 equal pieces. When we're thinking about the sizes of these pieces, always think about what the denominator is telling us. Moving on to number 12, we see Gabby brought 8/9 of a pound of puppy chow to a party. Nicola brought 2/3 of a pound of Chex Mix. Write a comparison statement. So again, my friends, we are just going to use that handy dandy fraction comparison machine. Again, you can use it free of charge in 3rd grade. If you try to use this in 4th grade, I will bill you. Just kidding. I won't bill you. I'm going to work on drawing a straight line. Okay, that one's much better. And we love our super duper fraction comparison machine because we know that both of the holes are going to be the same size. I cannot compare fractions if the holes aren't the same size. So that's why this really, really is nice. Okay, 8/9 early and 2/3. I'm thinking, I have to cut this into ninths. Okay, I'm going to try my best. I'm going to do thirds. And then I'm going to cut each of my thirds into 3. And let me know how this looks. Actually, I feel like this is kind of okay. So we've got 9 equal pieces, and now I'm shading 8. As I'm shading 8/9, I don't know about you folks, but I'm thinking, this is pretty close to 1. This fraction's pretty big, even though there's 9 pieces. Almost all of the pieces are shaded except for 1. Let's look at 2/3. So I'm going to cut our whole into 3 equal parts, and then I'm shading 2. These pieces, you can see how long it takes me to shade them in, are much bigger than the 9ths. So this one is 1/9 away from being whole. This one's 1/3 of the way, 1/3 away from being whole. So when we're thinking about which one's bigger, you guys can see pretty clearly, or actually very clearly, that 8/9 is absolutely bigger than 2/3. We're supposed to prove this using a picture. Well, oops. A picture speaks 1,000 words. If my picture is going to cooperate with me, we can just see that very clearly. So use this strategy on your test, my friends. You will be completely confident that it's the correct answer. And it's just a thing of beauty. Look at how you can't argue with that reasoning. It's perfect. Speaking of perfect, I am completely confident that every kid in my math class is going to nail this problem. So let's look at this. Anne is comparing 5/6 to 4/6. Look at her model. So we have this circle showing 5/6, and then this giant rectangle showing 4/6. To the untrained eye, it looks like 5/6 is smaller than 4/6. Well, you guys probably immediately are immediately outraged knowing that Anne, and this is okay, Anne's on a journey, right? Anne has not retrained her brain yet. We honor everyone wherever they are. But you all know, because you've been working so hard, you guys know that 5/6 is bigger than 4/6. First of all, the denominators are the same, so we just have to look at 5 versus 4. And then I know you guys are outraged because you're probably thinking, Anne, if you're comparing fractions, use the super duper fraction comparison machine, because when you're comparing fractions, Anne, the holes have to be the same size. Are Anne's holes the same size? No, Anne's shapes aren't even the same. You can't do a circle versus a rectangle. That's how black holes are created. And if only you had Mrs. Calamaris for your math teacher, she would have told you that you can use the super duper fraction comparison machine for free of charge while you're in 3rd grade. But poor Anne does not have me as a teacher, this poor misguided 3rd grader. And she's trying to do a circle versus a rectangle. I know that no one in my class would pull such shenanigans, but here we are. So what we have to do for this problem, my people, is to put Anne on the right path. We can absolutely introduce Anne to the super duper fraction comparison machine, showing Anne, first of all, the holes have to be the same size if you're even going to think about comparing. And then we can show her, hey, Anne, 5 out of 6 actually represents a greater quantity than 4 out of 6. So she says 5/6 is less. No, not quite, Anne, but that's okay. If not, what mistakes did she make with her model? Explain using words. Anne did not use the same size holes. The same size holes. And this is like not a hole that you would dig in the dirt. This is like a whole one, because all this modeling of fractions, it's really showing one hole. So I would feel very good about this if you wanted to go ahead and go be a little extra and show what the comparison of 5/6 versus 4/6 actually looks like in Mrs. Calamaris' class. I am not going to stop you. But again, my friends, I feel really, really great that you guys are going to be able to handle a question like this because we've been kind of talking about this for quite a while. So we will plan on everyone nailing number 13. Lucky 13. Okay, 2 more to go, my people, and then I have to go downstairs and make dinner for my people in the house. Number 14, we are looking at Logan's planting a vegetable garden. He made room in 1/4 of his garden for tomatoes. Shade to show how many parts of his garden will have tomatoes. And then we're looking for an equivalent fraction. This is really nice because this is another one of our like double duty models. So we're going to look at 1/4 first. Do you guys see that this is cut into, we can circle 4 columns? And then you guys are also probably noticing that these columns each have 2 rectangles inside each of them. So yes, this is absolutely showing 1/4, but it's also showing something else. So if we're looking at the whole garden, everything inside of this purple blobby circle, how many boxes do we see? 1, 2, 3, 4, 5, 6, 7, 8. So yes, it's 1/4, but when we're looking at the whole garden, we're looking at an equivalent fraction that consists of 8 equal parts. And when we are using multiplication to create an equivalent fraction, we have to think about multiplying the denominator and the numerator by the same number. 4 times what number is 8? Ding, ding, ding. Yes, 4 times 2 is 8. If we're multiplying 4 by 2, we have to multiply 1 by 2. What is 1 times 2? 2. So 1/4 is equivalent to 2/8. We can see that here. Yes, we can see it as 1/4 if we're just looking at the columns, but we also see 2/8. Do you guys see how that's also 2 out of 8 shaded there? So this is another beautiful model of those equivalent fractions, and then we're supporting using our multiplication. 1 more to go here, rock stars, and we're going to be putting these fractions in order from greatest to least. So we have Rose is using 3 different colored ribbons to wrap a gift. That's going to be a gorgeous gift. She has 3/8 yard of purple, 3/3 yard of pink, and 3/5 of silver. Please promise me you will just never guess in life. If you have a strategy that will help you be 100% confident that you're correct, can you please promise me that you will use this strategy? Even use it in 4th grade, I promise. I won't charge you. I'll be very benevolent. I want you to always be confident that you have the right answer. And getting the right answer for this one is as easy as drawing a super quick, super impressive triple-decker fraction comparison machine. So top row is going to be 3/8. We are looking at chopping this into 8 equal pieces. I'm thinking about the pieces, and I'm thinking they're pretty skinny, and I'm thinking if this was chocolate cake, I'm not interested. I mean, let's be honest, these pieces are too small. So 3/8 looks like that. Our next fraction in the middle is 3/3. So I'm cutting this into 3/3, and I'm shading all 3/3. And you guys are probably thinking, well, Mrs. Calamaris, you're actually shading 1 whole, and you would be exactly correct, you brilliant little geniuses. Very proud of you. Okay, so 3/8 versus 3/3. Yeah, 3/3 is much bigger. We can see that. And now I'm going to cut this bottom floor into 5 equal parts, and I'm shading 3 of those. And the problem is asking us to put these in order from greatest, which means biggest, to smallest. So my friends, which one is the biggest? Indeed, 3/3 is the biggest. It is a fancy version of 1. None of these other ones are whole. 3/3 is whole. That's a whole number 1. These are other 3/8 and 3/5 are fractions of wholes. So the greatest is 3/3 or 1. What's the smallest? I like putting the smallest in. Well, yeah, 3/8 is the smallest. That puppy was cut into 8 equal bits. So we've got 3/3, biggest, 3/8, smallest, and then right smashed in between those is 3/5. So when we're looking to put these in order from greatest to least, we're looking at 3/3, 3/5, and 3/8. My friends, thank you for hanging in there. Thank you for being such hardworking, courageous mathematicians. I am so excited for you to show your greatness on Wednesday, and thanks for watching.